the problems we did yesterday started out with logs in them. And our goal was if we could just get a log by itself, then we could use the definition to change it into exponential form. The final type of problem we have is when everything has a log. And so in this scenario, we're going to go back to look at the front, the very first page of your notes handout. We had two strategies. We've done the problems where we had to add a log to each side. It works in reverse. If you have one log on each side, you can take them away. So that's going to be our goal. If we can get it to be a single log on each side, then they can disappear. So if I look at this problem. Okay, I need to get rid of this 2. Where does that go? So now you have a log on each side. That's just like getting a common base. When you have the same base on each side, you drop them. When we have the same log on each side, we can drop that. So that tells me x squared equals 9. How do you get rid of a square?
Square root.
And with that we need?
Plus or minus.
Yeah, x equals plus or minus 3. But we always, when we have problems with logs, we have to check our answers. Because when you're dealing with logs, the argument has to be positive. So when I put in my x, it has to be a positive number. So can I use both of these? No, we can't do the negative 3. So x equals 3 is our final answer. Is that okay with everybody? So second one. So this time they both have coefficients. So we turn those into the exponents. So then we can drop those logs, so x to the 1/2 equals 2 squared, which is just 4. Okay, a 1/2 power, remember, that's the same thing as a square root. So how do we get rid of that? So if you square one side, you square the other. So we get x equals 16. So then we check, can we put in the 16? Yep. So that's our answer. Okay, I have more logs this time. We have to get one log on each side in order to be able to drop them. So if I look at the left, I have 2 logs subtracted. What do we do there?
Divide.
So that would be the natural log of x over x minus 4. What's the natural log of x plus 6? So next step.
Drop your natural.
If I want to get rid of the fraction, we can multiply by the x minus 4 on each side. So we get x equals, we FOIL over here, x squared minus 4x and plus 6x is plus 2x minus 24. Darn, I made up this problem. It is not nice. Can I fix it? Can I make this a 2x right here? Okay. Well, that's still not going to make it really pretty, is it? It'll work. It'll work. So when I subtract that 2x over, those cancel, so we just get x squared minus 24. Sorry, apparently I didn't work out all my problems before I printed that. How would I get x by itself then? Okay. And then to get rid of a square root, or square, we add a square root, plus and minus. This doesn't work out perfectly, but we could break it up. 24 would break into a 4 and a 6, so that's plus and minus 2 radical 6. You can also give a decimal on these. You know, the Math Excel, sometimes it says exact value, sometimes it asks for the decimal approximation. That's like 4.899. So are both of those answers okay?
No.
No. The negative one would not work. So my answer is just a positive 2 radical 6. Is that one all right? Let's look at this one. What do we do?
Condense.
Do something.
Yeah. So these two logs are subtracted. So if we want to condense them into one, we divide. So it'd be x minus 1 over x plus 6. So on the other side, these are also subtracted. So we put them together by dividing. X minus 2 over x plus 3. So then we can drop our log. What would we do here?
Cross multiply.
So when you multiply these two, you have to avoid. So we get x squared plus 3x and minus x would be plus 2x. Negative 1 plus or times 3, negative 3. And FOIL these two, we get x squared minus 2x and plus 6x, plus 4x minus 12. Now what?
Gives you the same sign.
When I subtract over my x squared,
Cancels.
let's cancel. So we could just get our x over. So if I subtract over my 4x, that'd be negative 2x. Could add the 3. Equals negative 9. Divided by negative 2, so x is positive 9 over 2. We need to check it. That 9 over 2 is like 4.5. So 4.5 minus 1, 4.5 plus 6, minus 2 plus 3, all of those are positives. So this answer works. If even one of them came up to be a negative, what would we have to say? So we have officially done all the different types of problems. What I have on the remainder of this handout is just some extra examples with the different types mixed together. So why don't we go ahead and run through these and see if we remember all of our strategies. So the first one, what is our strategy here? It's an exponential. So what we did is we added a log to each side. So you could do whatever log, but we usually did log base 10. And then, why is that helpful?
You get the x's by itself.
So the log, or the exponent comes down. So these were like the two longer problems we did yesterday. So we have to
Split it.
distribute, yeah. So we get 2x log 3 minus log 3. Then what do we do?
Add the log 3 over.
Mhm. So we have to get the x's on the same side. So you can either add over the log 3 and subtract over the log 0.4, or bring over the 2x log 3. Either way is fine. So now both of those have an x, so we can factor that out. These were the longest problems that we've done. Then, how do we get to our final answer? So we have negative log 3 divided by log 0.4 minus 2 log 3. And you can, that's the exact answer. If I ask for a decimal, you type that in. Make sure you put parentheses around the entire denominator. And so we would get 0.3529. So we did some of that on Friday, and we did another one, some more yesterday. So those were the problems where we couldn't get a common base, so we added our log to each side. And this was the longest version of that because we had multiple x's in our exponent. Are we okay with that type?
Yeesh.
So what about this problem?
Natural log.
Right, we talked about when we add these logs, if we have e's, then natural log is helpful. What should I do before I add that natural log?
Put those together. You can multiply.
Yeah, when you're multiplying, what do you do with the exponents?
Add all.
So 4x plus x minus 1 would be 5x minus 1. So then you said to add the natural log. And why is the log so beneficial? What happens?
Because numbers out.
Okay. We know that in general, the exponent comes down in front, so that 5x minus 1 comes down. You could keep that natural log of e, but we know natural log is just log base e. And when the base of the exponential and log are the same, that just turns into a 1. So that can really disappear for us. Just save a little headache. But if you kept it, it's not a big deal. It's equivalent to 1. It's just not as pretty. So then,
Oh, wait.
Add the 1.
add the 1 and then divide by 5. So we have natural log of 5 plus 1, and then when you divide. So this would be our exact answer. If I asked for the decimal, remember you want to put parentheses around the entire numerator. And then every time you push the log button, it opens parentheses, so you have to close that one. So let's double check and make sure we can get it. Did you guys get 5?
Yep.
You need parentheses.
Okay, so we've really done several types of problems. We're reviewing all of them. So these are the exponential ones. Then yesterday we got into, we had some more exponential ones, but they were a little bit uglier. What do we need to do before we start throwing logs in?
Add the 5.
Yeah, we have to isolate that exponential piece. So if we add over our 5, then what?
Subtract by, or divide by 6.
Is it possible to get a common base? No. So we have to add our logs. Then what happens? Your exponent comes down. And you have really a couple different options for how to proceed from here. We only have one x, so we're trying to get x by itself. So we can distribute that log 3, or you can divide it over. It's not going to matter because eventually we're going to put it in the calculator and get the decimal equivalent anyway. So both ways will get us there. So if I divided that, and then what do we do? Subtract the 1. And then final step would be, yeah, take that whole answer and divide by 2. All right. So I'm going to type in log 2 divided by log 3.
Does the job need to be in parentheses?
Yes. So if you're going to type this in, put that in parentheses. Maybe it does. We have to Okay. Last one. I threw a trick on this one. So these are the problems we just did. We had the log on each side. And I said you had to get just a plain log. So what would I do with my 3? Okay. What would I do about this negative?
Times a negative 1.
Yeah, so this is just like a -1. So that means this exponent is a -1. So now we can drop the log. So we have x cubed equals, what is 27 to the -1?
127.
And then how do you get rid of a cube? Good. And we double check that the argument is positive, so we're good. So you now have time to